Algebra 2, Lesson 43 is about trigonometry, sine, cosine, and tangent, and inverse functions. Part A is focusing on sine, cosine, and tangent, and you can see here I've written some ratios for these, and that's really all they are. They are ratios of sides of a right triangle. The sine of A, okay, it's not sine times A, it's the sine of A. It's like f of x, it's function notation. The sine of A is the opposite side over the hypotenuse. So we have to talk about which those sides are, so these ratios make sense. Opposite means across from, and so opposite angle A here will be this one. So this is the opposite side. The hypotenuse is always the longest side of a right triangle, and it's always opposite the right angle. So this one is the hypotenuse. Okay, it is always opposite the right angle. And then the other side that makes up this angle, angle A here, is made by the hypotenuse, and this other side is the adjacent side. Adjacent means next to, and it's next to this angle. So this is adjacent. All right, so if I'm finding the sine of angle A, I would take whatever the length of the opposite side is divided by the length of the hypotenuse. Cosine is adjacent over hypotenuse, so it'd be the length of this side divided by the length of the hypotenuse. And then tangent is the name given to the ratio of the opposite divided by the adjacent. And we have a couple of different memory aids you can use to remember which one's which. The book actually has a variation of this, but a common one is Oscar had a heap of apples. O for Oscar, but also opposite. Had, hypotenuse, A, adjacent. Heap and hypotenuse both start with an H, and then O for opposite and A for adjacent. Oscar had a heap of apples, and that works well whenever you remember to have them in order: sine, cosine, and tangent, which is how I will usually be listing them, and that's the order you'll see them in on the calculator as well: sine, cosine, and tangent. There's another memory aid you might also like that I want to include here, and it's SOHCAHTOA. We have so, ka, toa. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So it's these same things, but written in a different way. Some prefer Oscar, some prefer SOHCAHTOA. However you prefer to help you remember which one's which, it's totally fine. Let's see. Now we're going to look down here and remember some things you know about similar triangles. Okay, if triangles are similar, all their angles are congruent, right? This is 30, this is 30, this is 90, this is 90, this is 60, this is 60. If that's the case, then the triangles are similar. And if triangles are similar, you know, you've worked with this a lot, their sides are proportional. Okay? That just means when we do these ratios, it doesn't matter how big the triangle is. If that angle's the same, then you'll still get the same ratio. You'll still get the same answer like when you reduce it or do it on a calculator. So for instance, we're going to look at the sine of 30 degrees here for all three of these. The sine of 30 degrees, looking at this triangle, sine is opposite over hypotenuse, opposite the 30-degree angle, and this one is a 2. The hypotenuse is 4, so that reduces to 1/2. Okay, looking at this triangle, the sine of the 30-degree angle, opposite over hypotenuse. This also reduces to 1/2, which is no surprise because they are similar triangles, and so the corresponding sides are proportional. And then just one more, Opposite is 120, hypotenuse is 240, and that again reduces to 1/2. This would also work for doing cosine and for doing tangent, because it's just ratios of these corresponding sides, and the corresponding sides are proportional. So it doesn't matter how big the triangle is, it just matters what the angle is. And it's in a right triangle. Okay, this is for right triangles. Otherwise, there would be no hypotenuse, because the hypotenuse is opposite the right angle. Okay. Then we're going to have to talk about how to find some of these things on the calculator, but we'll get to that, I think, on the next page here. So, yes, we will. Let's move on to that. Okay. Well, there's some room down there at the bottom. I think I'll just make some of the notes down here. When you're using a calculator, you do want to make sure your calculator is in degree mode. There's actually another way of measuring angles we're not getting into right now. And so since we're working with degrees, you need to make sure your triangle is in degrees. It usually will be. But I'll show you about making sure about that. So we'll make a note of that. And we'll be rounding, and I think I have a note about that on the next page. Because we'll get, they don't often come out to nice things like 1/2. Okay, so yeah, we'll just say when using calculator, I better move that up. When using the calculator, be sure that it's, it's in degree mode. And there are different calculators are laid out different ways and do things slightly differently, but I'll show you the ones we're using in the classroom whenever we get to these, because I'll be needing that shortly anyway. So here in example 1, we're supposed to find the sine of A first, and then we'll get to the other ones. So for that part, the sine of A, please pronounce that correctly. The full words are in the heading of your notes. Okay, and how we usually write them is the same as the abbreviations on your calculator keys. And I know it looks like sin, but it's still pronounced sine. Okay, it's sine, cosine, and tangent. Anyway, so we're doing the sine of A, and that is opposite over hypotenuse. Opposite angle A here will be the 4. And the hypotenuse is always the one opposite the right angle, that is 7. Okay, so the exact answer for this is 4/7. But we often do work with decimals with these, and so we'll also get a decimal answer, so using the calculator. And for this part, you're just doing a normal fraction, normal division problem. It doesn't matter what mode it's in. But I'll just mention here, while I'm thinking about it still, right there, that DEG, that's for degree mode. You don't want to see rad or grad. They're for other things. Okay, you want the DEG for degree. If it's not in that mode whenever you're using your calculator, on ours, it's this DRG button. Okay, I hit that, and then I can choose from those 3 things. And you just arrow over to choose the one you want. If it was already on radians, I could arrow a couple of times to get to degrees, or let's go back to the left, and then, whoop, then it's trying to focus again. And then you would hit enter, and then you're good to go. Anyway, so 4 divided by 7, 0.57 if we use 2 decimal places, so it's approximately, it's a wavy equals for approximately equal to 0.57. Okay, the exact answer is 4/7, but we sometimes do just want a decimal, so we have that. Then for B, we're supposed to do the cosine. The cosine of B is, okay, so cosine is adjacent over hypotenuse. Adjacent is the side next to the angle. That's not the hypotenuse. So this one, 7, and then the hypotenuse is 8.6. We definitely would never leave our answer like that. That's a complex fraction. Even if we were keeping a fraction, we would not leave it like that. So let's see, on the calculator, I have 7 divided by 8.6, and I'm getting approximately 0.81. And then for C, we're doing the tangent. The tangent of C is, and that one's opposite over adjacent, so that is 6 over 8, which, you know, is 3/4, so even without a calculator, and now I don't need to do approximately, that's exactly 0.75. Okay? That's all there is to it. You just figure out which sides you're doing the ratios of and do it on the calculator. And if you're rounding, it's good to put that wavy equals. It's approximately equal to. And then I think we're done with part A. And part B is pretty short. We do have some blanks to fill in, and I did some of this for you ahead of time. So inverse functions. We're just talking about inverse trig functions right now. And to do that, well, the inverse sine, for example, of a number is the angle whose sine is that number. So the sine of 30 degrees is 1/2. We saw that already, I think. We did. The sine of 30 degrees is 1/2. So the inverse sine of 1/2 is 30 degrees. It's like multiplying and dividing are opposite, adding and subtracting are opposite. It's that sort of thing. The sine of 30 is 1/2, so the inverse sine of 1/2 is 30. Okay? The cosine of 30 is approximately 0.866, so the inverse cosine of 0.866 is 30 degrees. The tangent of 30 degrees is approximately 0.577, so the inverse tangent of 0.577 is 30 degrees. This matters because sometimes you know the sides of, like all the sides of a triangle, but you need to find the angles. And so we use the inverse functions for that. When you're just trying to find the length of a side, you use sine, cosine, or tangent. But if you're finding an angle, then it's the inverse of those. And to use a calculator to find the inverse sine, cosine, and tangent of a number, it varies. Like I mentioned, calculators vary, but the ones we're using in class, you press the second key, which is in the top left, followed by the trig function. So if you're doing, let's see, why don't we go ahead and do on the calculator, I'll try not to let it glare this time so you can see it, the inverse sine of 1/2. Okay, so I'll clear this out. We'll try this again. Okay, hopefully this will work out. You can see it. So inverse sine, I hit second, sine, and then, so you see the sign of the -1, that's the symbol for inverse sine. I should write that in the notes, of 1/2. Okay, and that equals 30 degrees, which we knew from before. The inverse sine of 1/2 is 30 degrees because the sine of 30 degrees is 1/2. But that sign to the -1 that you see up there, that's not an exponent. That's just notation for the inverse sign, which unfortunately looks like an exponent. That's what that is. So let's see, inverse sign. Symbol for that is sign to the -1. There's actually another one, and it's arc sign. There, sign to the -1 looks like we're arc sign. But even this, you would not say sign to the -1. That's just inverse sign. Or arc signs, they're the same thing. Anyway, that's that. That's how you do them on a calculator. And looks like we've got another example to do down here. Actually, our last example. So, there's an A and a B to this one. Find for A the angle whose sine is 0.643. So that means we're looking for an angle. We're doing the inverse sine. So inverse sine of 0.643. That's what I'm doing on the calculator. I hit second sine 0.643 equals. Okay, so here we go. Try this again. What was it? 0.643. Okay, second sine 0.643 equals. Okay, so about 40 degrees. See, 40.015 ... So is approximately 40 degrees. I know we were doing the sides to hundredths. We often do degrees to whole numbers or maybe tenths. So I'm just going to write 40 degrees for this. And then the other one, I'm not going to keep putting the calculator into the camera, but for B, I should have labeled that A. For B, we're finding the angle whose cosine is 0.216. So then the inverse cosine of 0.216. Okay, so now I hit second cosine 0.216, and I'm getting 77.5257 ... So we're going to say approximately, well, the book was inconsistent. They did this one to the nearest hundredth. I would tend to just say 78 since we said 40 for the other one. I'm just going to fix the other one. We'll stick with going with hundredths. So for this one, 77.53 approximately. And that other one, I sort of forget, was it 0.01 or 0.02? Inverse sine of 0.64302. Okay, 40.02 degrees. There. We'll just keep it simple and always do hundredths for now. And that's it for the notes. Have fun with sine, cosine, and tangent.